2.4 algebraic reasoning. I've also included a little bit of 2.6 because for the most part we are skipping chapter 2, but there are a couple important things that we need to know before we can move on. All right, so your essential question is, how can algebraic properties help you solve an equation? And you've done this in algebra, so we're just going to review. This is all review. So our algebraic properties of equality means that we use these when two things are equal to each other, or in other words, like in an equation. Okay, so we're going to let A, B, and C be real numbers. That's all we work with in this class anyways. The first property is the addition property of equality. Okay, so the addition property of equality basically states that if you have an equation such as A equals B, then you can add the same thing to both sides, and that's still going to be true. Right? So I can add C to both sides. I'm adding the exact same thing to both sides. Still a true statement. For example, if I have, I don't know, let's say x minus 3 equals 5. Well, when you're trying to solve this, you're going to use that addition property of equality, because basically what you're going to do is you're going to take this negative 3, you're going to do the inverse of that, so you're going to add 3 to both sides, and that gives you x equals 8. Right? And so that's how we solve equations. We use these properties of equality. Okay, and the next one is subtraction property of equality. So we subtract C from both sides, still keeps it equal because we did the exact same thing to both sides. The multiplication property of equality, right here we're going to multiply both sides by C. And this says C can't equal 0 because if it does, it basically makes everything 0. And the last one is the division property of equality. Again, we divide both sides by C. As long as we do it to both sides, we are totally fine. Unless C is equal to 0, you can't divide by 0, so that would be an issue as well. Okay, and then the last property is the substitution property of equality. So this one basically says if I have an equation like A equals B, or I have two things that equal each other, then I can substitute A in for B, or B in for A, or whatever. Okay, so we use this a lot. For example, if I gave you, I don't know, 3x plus 2, and I told you that x equaled 7. Well, you can use substitution. You just take this value of 7 and you plug it in, right? So this would be 3 times 7 plus 2. Or in other words, what would that be? 23. We use this a lot in another way, too. So in Algebra 1, you learned about if you had two equations. For example, if you had y equals 2x plus 3 and y equals 6x minus 1. Those I have two equations that are both equal to y. So what I can do, if for example, the directions were to solve this, well, the solution to this system is going to be a point where these two equations intersect. So let's see. I'm just going to draw a really bad graph of this. But let's say, for example, this one grows faster. So I've got two lines that look something like this. They're going to intersect in some point. I can easily solve this using that substitution property of equality and figure out what x and y are where the two lines intersect. They're lines, so I'll put little arrows on the ends. Well, how do I do this, you ask? Well, notice how they're both set equal to y. So I can literally just take this piece that is set equal to y, plug it into the other one for y. So I can end up with an equation that is 6x minus 1 equals 2x plus 3. And now I can continue solving this for x. So maybe I'll subtract 2x from both sides. At the same time, I'll go ahead and I'll add 1 to both sides. So I ended up with 4x equals 4. Divide both sides by 4. I get x equals 1. All right, well, now I know x equals 1. I can now take that, substitute it back in to either equation, doesn't matter, you'll get the same thing, and figure out what y equals. Well, y will equal 6 times 1 minus 1, or 6 minus 1, which is equal to 5. So basically now I know that these two lines, this y equals 2x plus 3 and y equals 6x minus 1, they intersect at this point 5, 1. Or sorry, 1, 5. X comes first. 1, 5. They intersect at the point 1, 5. So just a couple of examples where we use that substitution property of equality in our algebra. Okay, example 1, we're going to justify each step for this. So we have to solve it. And we're going to solve this using like a 2-column proof. Okay, so I'm going to do 2 columns where I go statements, and then my reasons for those statements. What allows me to do that stuff? Okay, so my first statement is just going to be the original equation. Well, what was my reason for doing that? Well, this was given to me. This is what I'm trying to solve, right? Now, to solve for x, I need to undo or do the inverse operation of every single thing that's happening to x. 2 things are happening to x here. One is being multiplied by 2, and it's also being subtracted by 5. To make your life easiest, you should undo addition and subtraction first, because if you divide everything by 2, you're going to end up with some decimals, and then you're going to have to do some more math with those decimals or with those fractions, and it's going to be a little bit ugly. So I like to kind of think of this sometimes as PEMDAS backwards. When I'm solving, I'm kind of doing my order of operations backwards. So I'm going to undo the addition or subtraction first. So here, to get rid of this negative 5, I will add 5 to both sides. And that leaves me with 2x equals 18. Okay, so for step 2 here, I ended up with 2x equals 18. What got me there? Well, I added 5 to both sides. So the property of equality that I used by adding something to both sides is the addition property of equality. I'll just abbreviate addition prop of equality, or equal sign. Okay, now the next thing I need to do to get x by itself is I have to undo the 2. The 2 is being multiplied to x. So to undo that, I divide both sides by 2. That's going to leave me with, let's see, that gives me x equals 9. So for my third step, I'm just left with x equals 9. Well, what did I do? I divided both sides by the exact same thing. So that right here is the division property of equality. Oh, let me write that out. We'll abbreviate prop of equality, but I think we'll write out the rest of it. Division prop of equality. Okay, so we solved it and we justified each step using our properties of equality. So you've just done like a 2-column proof. We're just going to do the algebra proofs this year. Okay, now you probably all remember the distributive property. So the distributive property basically says that if you have A times 2 things inside parentheses that you can't combine, and they're being added together, well, you can multiply this A to both things or both terms, and you'll get A times B plus A times C. You can also do this over subtraction. We use this when we can't combine what's in the parentheses. So for example, here, notice I can't combine x and 1. If I had like a number here like 4, well, I could add those together and get 5. So I would do that first. But here, you know, order of operations says that you should always do your grouping symbols first. And I can't do anything with these grouping symbols because x plus 1, those aren't like terms. So instead what I do is I distribute. Okay, so that's what we're going to do first. Now again, we're going to justify each step. So I'm going to write a 2-column proof once again. Okay, so the first step is always to write the original problem. And the reason we can do that is because that was given to us. Okay, so now the second step, I'm going to go ahead and distribute the 2. So when I do that, 2 times x is 2x. And then I also have to multiply that 2 to the other term in the parentheses. So 2 times 1, which is positive 2. So the reason that I was able to do step 2 was because of the distributive property. And from here, I'm going to go ahead and solve for x. So I notice that 2 things are happening to x. It's being multiplied by 2. It's being added by 2. I'm going to undo this addition first. And the inverse of addition is subtraction. So I end up with 2x equals negative 6. That'll be my third step. And what allowed me to do that? Well, I subtracted 2 from both sides. So that was that subtraction property of equality, right? I subtracted the same thing from both sides. The last thing I need to do to get x by itself is I need to undo this multiplication of 2. So I'm going to divide both sides by 2. So x equals negative 3. Okay, and what allowed me to do that? Well, again, I divided both sides by 2. So that is called the division property of equality. Okay, moving on to example 3. So we're going to use the formula P times the quantity 1 plus R times T equals A to find the value A of an investment. So this is actually an interest problem where P is the original principal. So let's see, A is the value of an investment. P is the original principal that you invest. R is the rate of simple interest. We have to write our rates as decimals. They're usually percents. And T is the time in years that the money is invested. Okay, this is a simple interest. When you get to Algebra 2, we'll do a whole bunch of other interest formulas, but this is a very simple interest formula. And you want to invest your money, right? So you take your money maybe to the bank, and you give them your money, and the bank, for borrowing your money, gives you an interest rate. Now, at the bank, it's a very low interest rate, but they will give you an interest rate where every so often, maybe it's every month, maybe it's every quarter, it depends, they add money. They give you a percentage of the money back that you have invested. So it adds on. Another place where you invest your money is the stock market. Now, in the stock market, you take on a lot more risk because stock prices go up, they go down, they fluctuate a lot, but you also earn a percentage of the amount that you invested, and that gets added to your initial investment or your original principal that you invest. Okay, so we're going to solve the formula for T. So we're going to start with this formula. I'm going to write A first. So I'm going to write A equals the principal times 1 plus R times T. So again, this is the amount that you get after a certain amount of time. This is the principal. That's the original amount that you've invested. R is the rate. So for example, if you invest your money in the stock market, sometimes you get like a 5 or 7 or 9% interest rate return. If you invest in like a bank, could be less than 1% interest return. Okay, so banks, if you just put it in a savings account, you get a percentage of 1%. It's very small. And T is your time. Okay, so we need to solve this for T. Now, it doesn't say that I have to show every single, or it doesn't say I have to explain every single step like this one did. So I'm not going to have to justify every step. My problem here is that T is in the parentheses. I got to get T out of those parentheses, and I got to get it by itself. So I look into my parentheses, and I say, can I combine that stuff? Nope, none of it's like terms. So the first thing I'm going to do is I'm going to distribute. So I'm going to keep my equation going exactly like it is. So I'm going to keep that equal sign exactly where it is. And I'm just going to do steps to each side. And then I'm going to try and get t by itself. So I'm going to keep that a. Distribute the p, right? So p times 1 is 1p, or just p. P times rt, well, that's going to be a positive prt. Right? Because p times r times t is p times r times t. Okay. So now from here, I got to work on getting t by itself. Okay, I'm going to undo everything that's happening to t. One thing that's happening is it's being added to by this p. The reason I know it's being added to is because this is a positive p. It's also being multiplied by r and p. So I'm going to have to undo all of these things. I'm going to undo my addition first. So I'll subtract p from both sides. I'm going to kind of put it off to the side. If these aren't like terms, you can't actually subtract them. You can't combine them, I should say. You can just write them as a subtraction problem. So this is a minus p. P minus p gone. So I'm just left with p times r times t. Okay, still got to get t by itself. Again, t is being multiplied by r and by p. So in order to undo this, I'm going to divide both sides by pr. So those reduce, and you're just left with t on the right-hand side. And then you can leave this as a minus p over pr, or you can divide it up. So another way you could write this is a divided by pr minus p divided by pr. Right? Those are the same exact ways of writing this. The cool thing about this way is now you can even simplify a little bit more. Right? The p divided by p becomes 1. So this would be a over p times r minus 1, right? These reduced and gave us 1s. 1 over r equals t. Either one of these is totally fine. So you could use this one or you could use this one. Both of those are 100% correct. This one, you can just stop there. It's easier, but it's important that you know how to do this. All right, so we did the first part of this. So we solved the formula for t. That was the first part. You will have like a problem like this on your test, and everybody just does the second part without doing the first part. So this would get you a point on a test. Okay, now the second part of this is how many years will it take until a principal of $250 grows to a value of $285 when the simple interest rate is 2%. Okay, so how many years will it take means I want to know what t is. Well, look, I've got a formula that's already solved for t. Either one of these will work. Principal, my principal is $250. Okay, and it's going to grow to a value of $285. Okay, well, the value of an investment was A, so we'll let that be A. When the simple interest rate is 2%, so that's when R is 2%. But let's remember, we don't really do math with percentages. We change them into decimals. Okay, so instead of using 2%, 2% is the same as 2 divided by 100. Well, in 2 divided by 100, you basically, to make that into a decimal, you take your decimal, which is right here, and you go backwards 2 decimal places. So this would be 0.02. So I'm going to use this number, not that number. That's not going to get you the right answer. We always do our math with decimals instead of percentages. So I'm going to take this formula right here, and I'm going to plug in, let's see, I'm going to plug in P and A and R, and I'm hopefully going to get T. Okay, so let's come down here. I could have used this one too. There's no reason why I'm not. This one's just a little bit, maybe combined together. It's going to be a little easier. Either way, I'm going to get on my calculator. All right, so A is 285. P is 250. Again, P is 250 here. Times 0.02. Okay, oops, and that's going to give me t. All right, so 285 minus 250 is going to give me 35. And now, I guess the question is, what is 2% of 250? So I can go 0.02 times 250 is 5. I could have also thought about what's 1% of 250, which would be 2.5, and then double that. But either way, it's 5. So here the time is 7. I think that's 7 years. Let's make sure that time is happening in years. Time in years. Okay, so I will say in 7 years, I will have earned, well, I originally invested $250 and it's going up to $285. So I would have earned $35. So you can see that investing a small amount of money at a really small percentage rate doesn't get you very much, right? You get $35 in 7 years. Now imagine if you invested this at a higher percentage rate. So you do a riskier investment. Maybe you get 9%. And imagine if you invest a whole lot more money. Okay, then your money is going to grow a lot faster. And we'll talk a lot more about that in Algebra 2. Okay, so in 7 years, let's see. How many years will it take until a principal of 250 grows to a value of that when the simple interest? Yep, so we answered the question. It's going to take 7 years. All right, these come from section 2.6. I just added them into these notes, and they're quite simple. We've got a couple postulates. Remember, postulates are just like, they're just things that we accept. And I think that you will understand why we accept these in a minute. So if two angles form a linear pair, then they're supplementary. Well, a linear pair of angles forms a line. So it makes sense that if they form a straight angle or a line, then they add up to 180. They are supplementary. Okay, so we can say if two angles form a linear pair, then they are supplementary. Or in other words, measure of angle 1 plus measure of angle 2 equals 180 degrees. That one was probably self-explanatory. The next one, you don't already know this, but this is very important. So vertical angles congruence theorem is basically that vertical angles are congruent. So angle 1 and angle 3 are vertical angles. These two angles are congruent. Angle 2 and angle 4 are also vertical angles. So angle 2 is going to be congruent to angle 4. And I'll use 2 arcs for that. So we can differentiate because we can't necessarily say that angle 1 is congruent to angle 4. Although angle 1 and angle 4 do form a linear pair, so they're supplementary. Okay, so we're going to, for example 3, we'll use the diagram and the given angle measure to find the other 3 angle measures. So I know that the measure of angle 3 is 128 degrees. Well, then what's the measure of angle 1? Well, the measure of angle 1 is the same as the measure of angle 3 because they're vertical angles, right? So I know that the measure of angle 1 is also going to be 128 degrees. All right, well, the measure of angle 1 and the measure of angle 4, look at that. Those form a linear pair, right? They form a straight angle. So then I know that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. Measure of angle 1 is 128 degrees plus the measure of angle 4 equals 180. Solving for the measure of angle 4, I'm going to subtract 128 degrees from both sides. And the measure of angle 4 will equal 52 degrees. Okay, so we found the measure of angle 4. And what's true about angle 4 and angle 2? Well, those are vertical angles. So what's true about their measures? All vertical angles are congruent, right? So I also know that measure of angle 4 is equal to measure of angle 2. So therefore, measure of angle 2 has to also be 52 degrees. think we found all three missing angles. Okay, so we already had angle 3, so we don't have to find that. So we found 1, 2, and 4. And then we'll do one more. Again, we know that these two angles that we're given values of, well, this one's a variable expression, but we're given something about it. Those two are vertical angles because they share a vertex and they form two pairs of opposite rays. So here's one pair of opposite rays, here's the other pair of opposite rays. And we know that vertical angles are now congruent. We know that. Okay, that's been given to us. So that's just that's a theorem. Okay, that can be proven. We're not going to prove it though. So just accept it as truth. 4x minus 3 is going to equal 101 because vertical angles are always congruent. Okay, so we're going to add 3 to both sides. We get 4x is equal to 104. Divide both sides by 4. X equals, let's see, that goes in 2. That gives me 8, 24, so I think that's 26. So x is going to be 26. Let me just double check that real quick before I let you go. Yep, 26. And it's that easy.